In 1971, somewhere in the White Sea, a Soviet submarine accelerates past 40 knots. The hull begins to vibrate. The noise inside becomes deafening. And 82 men hold their breath as their vessel pushes toward a speed no submarine has ever reached before, and no submarine has reached since. The needle climbs past 44 knots, 44.7, 51 miles per hour underwater. The captain orders the engines cut. The test is over. They have just set a world record that will stand for more than half a century. But this triumph contains the seeds of its own failure, because the Soviets have just built the fastest submarine in history, and they will never build another one like it. This is the story of K-222, the submarine the Soviets called Goldfish, the vessel that proved speed alone cannot win an underwater war. To understand why the Soviet Union spent 1% of its entire naval budget on a single submarine, you have to understand the strategic nightmare they faced in the early 1960s. American aircraft carriers dominated the world's oceans. These floating air bases could project power anywhere on Earth, and Soviet surface ships had no realistic way to stop them. The admirals in Moscow needed a weapon that could hunt carriers, something fast enough to intercept them, deadly enough to sink them, and survivable enough to escape the aftermath. They needed a submarine unlike anything that had ever existed. In 1959, the Soviet Navy commissioned Project 661. The design bureau given this impossible task was SKB 143 inches Leningrad, led by chief designer Nikolai Isanin. His instructions were straightforward in their ambition. Create a submarine capable of speeds exceeding 40 knots while carrying enough firepower to destroy an American carrier battle group. Isanin knew immediately that steel would not work. A steel hull strong enough for high-speed operations would be too heavy. The drag forces at 40 knots would require more power than any existing reactor could generate. He needed a material that was lighter than steel, stronger than steel, and resistant to seawater corrosion. The answer was titanium. No one had ever built a submarine from titanium. The metal was notoriously difficult to work with. It required specialized welding techniques in argon-filled chambers. It was expensive beyond reason, and the Soviet Union had never attempted anything like it. But titanium offered something steel could not: a hull that weighed 40% less while being equally strong. That weight savings translated directly into speed. Construction began at Severodvinsk in 1963. The challenges emerged immediately. Titanium welding required absolute atmospheric control. A single trace of oxygen during the welding process would create brittle joints that could crack under pressure. The shipyard had to construct sealed chambers filled with pure argon gas. Welders worked in what amounted to spacesuits. The double hull design added another layer of complexity. K-222 featured an inner pressure hull surrounded by an outer hydrodynamic hull, both constructed from titanium. The space between contained fuel tanks, ballast systems, and equipment that would have cluttered the interior of a conventional submarine. The propulsion system matched the hull's ambition. Two VM-5 pressurized water reactors generated 177.4 megawatts of thermal power. This fed into steam turbines producing approximately 80,000 shaft horsepower, driving two massive propellers. For comparison, a Los Angeles-class American submarine produces roughly 35,000 shaft horsepower. K-222 had more than twice the power. The hull form itself was revolutionary. Naval architects had studied torpedo shapes, whale profiles, and hydrodynamic theory to create the lowest drag configuration possible. The result was a vessel 106.9 meters long with a beam of 11.5 meters, displacing 7,000 tons submerged. But speed was not the only innovation. K-222 carried 10 P-70 Amethyst cruise missiles in launchers built into the hull forward of the sail. NATO designated these weapons SSN-7 Starbright. They represented another first: submarine-launched cruise missiles that could be fired while submerged. Previous anti-ship missiles required submarines to surface, making them vulnerable. K-222 could attack a carrier group from depth, then use its extraordinary speed to escape before the escorts could respond. The submarine was commissioned on the 31st of December 1969. Captain First Rank Yuri Golubkov took command of a vessel that existed nowhere else on Earth. His crew of 82 men would spend the next 2 years learning how to operate a machine that defied everything they knew about submarine warfare. The test to determine maximum speed came in 1971. No one knew with certainty what would happen when K-222 pushed beyond 40 knots. The hull had been designed for these forces, calculated by engineers using slide rules and early computers. But theory and reality do not always agree 300 feet underwater. Captain Golubkov ordered the submarine to test depth. The reactors came up to full power. In the engineering spaces, the turbines screamed. The propellers bit into the water with 80,000 horsepower of force. 30 knots. The speed most submarines consider their maximum safe limit. K-222 was just getting started. 35 knots. The hull vibration intensified. Crew members reported difficulty hearing each other, even while shouting. 40 knots. The noise became physical. Men could feel the sound in their chests. The titanium hull flexed microscopically under forces that would have crumpled steel. Then, 44.7 knots. The instruments confirmed what no submarine had ever achieved. K-222 was moving through the water at nearly 52 miles per hour, deeper than most buildings are tall. Golubkov ordered the engines cut. The submarine coasted, gradually slowing as drag overcame momentum. The test was complete. Every man aboard understood they had just participated in something historic. But even as they celebrated, the captain knew something troubling. He had felt it the moment they passed 40 knots. The submarine that was supposed to hunt American carriers had a fatal flaw. At maximum speed, K-222 was the loudest object in the ocean. The very qualities that made her fast made her detectable. Those massive propellers, spinning at rates necessary to push 44 knots, created cavitation, the formation of tiny vacuum bubbles that collapse with audible pops. The turbines transmitted vibration through the hull. The water flow over that record-breaking hull generated noise that propagated for hundreds of miles. American SOSUS arrays, the network of hydrophones positioned across the Atlantic and Pacific, could hear K-222 from distances that made her speed advantage meaningless. What good was 44 knots if every NATO anti-submarine warfare asset knew exactly where you were the moment you accelerated? The Americans had spent 2 decades perfecting the art of quiet submarine operations. They used isolated mounting systems, slow-turning propellers, anechoic tiles, and precise engineering to make their submarines as silent as possible. Speed was secondary to stealth. The Soviets had built the opposite philosophy into titanium. There were other problems. K-222 had cost approximately 2 billion rubles to construct, roughly 1% of the entire Soviet naval budget for those years. A fleet of these submarines was financially impossible. The Soviet Union could barely afford one. The titanium hull created unexpected maintenance challenges. Where titanium components met non-titanium fittings, galvanic corrosion accelerated. Seawater acted as an electrolyte, causing different metals to corrode each other at alarming rates. K-222 required constant attention to joints, valves, and connections that would have lasted years in a conventional submarine. The reactor systems, pushed to their limits to generate that record-breaking speed, demanded more maintenance than standard Soviet submarine plants. The crew spent more time in port than at sea during the submarine's operational career. K-222 served primarily as a test bed after the speed trials. She conducted missions, gathered intelligence, and proved various technologies, but she never led a class of sister ships. She remained alone, the single example of Project 661, proof that certain engineering problems cannot be solved simply by building something faster. The Soviets learned from her. Later, titanium submarines, including the Alpha class and the massive Typhoon ballistic missile submarines, incorporated lessons from K-222's construction challenges. Soviet naval architects understood titanium welding because K-222 taught them. They understood the trade-offs between speed and stealth because K-222 demonstrated them in the harshest possible terms. The nickname Goldfish captured something essential about this submarine. She was beautiful, exotic, and impossibly expensive. She shimmered with technological achievement, and she could not survive outside carefully controlled conditions. K-222 was decommissioned in 1988. She spent the next 20 years rusting at Severodvinsk, too expensive to operate, too expensive to scrap, too historically significant to simply forget. The titanium hull that had once been her greatest advantage became a disposal problem. Cutting titanium requires specialized equipment. The process takes longer and costs more than scrapping a steel vessel. Between 2008 and 2010, K-222 was finally dismantled. The fastest submarine in history was reduced to metal fragments, reactor components requiring special handling, and memories held by aging men who had served aboard her. Captain Yuri Golubkov, the man who commanded her during the speed record, lived long enough to see the submarine he pushed to 44 knots become a historical footnote. He understood what the experience meant better than the engineers who designed her or the admirals who commissioned her. He had felt the hull flex. He had heard the noise that betrayed them. He had known, in that moment of maximum speed, that they had built something that could never win the war it was designed to fight. The record stands. More than 50 years later, no submarine has officially exceeded 44.7 knots. Modern nuclear submarines operate in the 25 to 33 knot range, accepting slower speed in exchange for the quiet that keeps them alive. K-222 proved that raw capability is not the same as military utility. She could outrun anything in the ocean. She could not hide from anything in the ocean. In submarine warfare, the second limitation matters more than the first. The engineers who built her were not wrong. They solved the problem they were given: build a submarine that can exceed 40 knots. They succeeded brilliantly, but the problem they were given was the wrong problem. Stealth wins submarine wars. Speed provides a temporary advantage that disappears the moment your enemy knows where you are. K-222 taught this lesson in titanium and shaft horsepower. The Soviet Navy learned it. Every submarine designed after her reflected that understanding. Somewhere in the depths, submarines still patrol in near silence, moving at speeds that would have seemed slow to K-222's crew. They survive because they cannot be heard. They complete their missions because no one knows they are there. The fastest submarine in history sits in pieces now, scattered across a Russian scrapyard. But her legacy moves through every submarine that chose quiet over speed, patience over power, survival over records. The Goldfish glittered once. Then, the ocean swallowed her whole.